Hey everyone, this is the second episode or maybe second session, which you can call from the previous session. I hope that you have gone through that because this is the continuation, and if you don't watch the previous video, this will be kind of confusion and you'll be having some doubts. But this will be basically we'll talk about the ecosystem of Hadoop. So let's begin. When Hadoop was first released, so again it was released in 2006. If you know, Yahoo had implemented that and we had covered this, so that's the reason why I'm telling you to go and watch the previous video. This is the second session, so that you will keep up. So Hadoop was first released in 2006. Actually, the thing is, Yahoo had implemented the white papers produced by Google, so that the version was Hadoop 1.0. So during that time, it had only two components in the Hadoop, which was Hdfs and Mapreduce, where Hdfs is the distributed storage and Mapreduce was the processing part, that is distributed processing. Now Hdfs means Hadoop distributed file system. So basically, like in the storage, you should not think that it is in the tables or maybe in the data frames, but rather this was storing in the form of files. So this had some like issues. So what the issue was, Mapreduce was a big component, meaning this was a huge component. This was most of the heavy tasks were actually conducted by the Mapreduce. So this has to do a lot of activities. It was getting bottleneck there. If there was a way to give some part of the work to other component apart from Mapreduce, then it would save some bottleneck, and that is exactly what they did in the next version. This new component which they have created, they call it as yarn. Now yarn also contains some new capabilities which were not there in Hadoop 1.0, but that story is different for some other discussion. But these are not all the only differences. But yeah, yarn is nothing but yet another resource negotiator, YARN. This mainly is responsible for the resource management. Think of it is like a Windows operating system. Whenever you open multiple processes, like you open a VLC player or a media player, you open up a song and you open up a Windows, some folder, and you open a browser, Google Chrome. So when you're requesting to open, what's happening is it is going and requesting the Windows operating system, hey, I want to open this, can you please give me resources? And that's when your laptop CPU is giving this processing power that, okay, if you want to open Google Chrome, here is the processing power, open it. That's how Windows is doing. So the same exact thing is happening in Yarn. Yarn is not just running on one system. If you remember from the previous video which we had discussed, this distributed computing is a cluster. There are multiple machines connected in the like as a cluster. There will be one machine connected to another machine. So yarn will not be just running on one system, rather yarn will be running on multiple systems. If there are 4 node cluster, or let's say 5 node cluster, in all the 5 machines yarn will be running. Okay, that's what I mean. So this is the new version, that is Hadoop 2.0, that was released in 2013. Now let's look at the whole ecosystem. We want to discuss about the whole ecosystem. The whole ecosystem sort of looks like this. You don't need to know everything, but we will discuss most of the things. We will not discuss Apache Ambari, we will not discuss rcrlog and Apache thrift server. No, we'll not be doing that. So sort of we'll be covering rest of the things. Flume will not be covering because these are not actually used much in present generation. These are outdated. Maybe you can say it as a legacy system. Apart from that, there are new tools that have come up, but yeah, we'll discuss most of the things which are available on this. So as you can see, this is Hadoop HDF. These 3 things combined together is called core Hadoop. The violet, the purple, whatever, maybe I'm colorblind, but yeah, these three, Hdfs, Yarn and Mapreduce, we just discussed that these three components form Hadoop 2.0, that is the second version, which contains Hdfs is Hadoop distributed file system, Mapreduce is for data processing, and Yarn is for resource management. On top of this, there are tools like Zookeeper, Pig, Hive, Mahout, we'll not discuss about Drill, there is HBase, Oozy, Scoop, yeah, and there are other tools, but this is more or less you can cover, but we'll discuss majority and more important ones in this. Okay, the first one, let's discuss about the Hive. Now, you do remember that in the previous session we had told that you should Java, it was the language which was used to code during the Hadoop 1.0. So not everyone knows Java. Does that mean the developer cannot work on big data anymore? Does not mean like that. So even those who know SQL can also work on it, but in the background it will be converted into Mapreduce code internally, meaning Hive is like a wrapper on top of Mapreduce. You write the code in SQL or and the Hive will internally convert it to Java Mapreduce code and trigger it on cluster. Okay, that is the meaning of Hive, and Hive is internally again a Mapreduce itself. So yeah, this was first actually developed by Facebook, and this is actually Hive is a open source data warehousing tool, to store large data sets, for data warehousing. Hive is actually used, and this, yeah, like I said, this is a wrapper on Mapreduce, and the query which you write more or less looks like a SQL query, but actually in fact technically it's called HQL in the sense Hive query language. It is very similar to SQL, only some of the functionalities which are there in the SQL will not be covered in the HQL. So it's not covered, it won't be supported in the HQL. So yeah, so if you know SQL, you can very well work on big data as well. Now Scoop. Now Scoop is let's say that you go to a shop, an ice cream shop, and you order a cone like ice cream where they used to get like a softie, which the cone will be separate, and when you push the button, the cream gets generated and the ice cream gets generated, and whichever flavor you like you can put on the cone. And that's exactly what's happening here. You can put any like ice cream on any cone, and whichever you like flavor you can choose. So what basically is happening is you can transfer the scoop one upon the other, like, isn't it, on the ice cream? Similarly, the scoop is to transfer the data from a traditional database to an Hadoop environment. Let's say that you have a data in Oracle DB, MySQL, or Microsoft SQL Server, or PostgreSQL, or you name it. You name any traditional database and you want to get the data into Hdfs. Then using scoop commands you can literally do that. Okay, a scoop is actually gives you command line interface, the command line kind of interface where you need to type the scoop commands and connect it to the driver and all those things you need to do, and that's an application for transferring the data between the relational database, that is the traditional database, to Hadoop. And also you can do the vice versa as well. If you have the data in Hadoop, you can still move the data from Hadoop, which will be in the format of the file system, but when you're transferring it will be converted to relational structured format also. So it's a very beautiful and very powerful tool, Scoop. And Scoop is usually called as a data ingestion or data migration tool. Again, Scoop is internally, again Scoop also will if you write the command line, but internally it converts it into Mapreduce job. But this is a special Mapreduce job. The reason why I am telling it as a special Mapreduce job is because in what is a Mapreduce? There is a mappers and there is reducers, isn't it? There is a code for mapper, there is a code for reducer, which was coded in Java before, but yeah, there is a separate code for both. But in case of Scoop, there will only be mappers, there will not be reducers. That is why it is a special kind of Mapreduce job where only mappers will work. Mappers are nothing but, again, these machines, like in a cluster, if multiple mappers are working on multiple virtual machines, where only mappers will be running, there won't be reducer, because we are moving the data. Reducer is nothing but, you know, you are aggregating the data. You want to count of someone, you want to find an average of something, you want to find the sum of something, you want to find the percentage of something. These are aggregations. Aggregations are done by reducer. Okay, but when you're transferring the data, why do you need a reducer? That doesn't make sense, right? You're not aggregating something, you're just pushing the data. So that's the reason only mappers are used. That's why it's called special Mapreduce job. But you don't need to take care of all these things. Everything happens internally. Now, next, pig. It looks funny, but yeah, pig is actually used to clean the data, especially and also to convert the unstructured data to the structured data. Well, basically not most companies use pig. This is not so important, but these are the two major problem it solves, that is to clean the data and then to convert the unstructured data to structured data. Now, if you remember the previous session, we talked about 8 V's, and also there was 4th V. The 4th V was the veracity. If you remember the 4th V, we talked about 8 V's. In that, the 4th V was veracity, right? What was that? That was, yeah, veracity. Pardon for my cases, but yeah, we talked about veracity. So veracity means to clean the data, because you cannot always expect the data to be in certain format. That's what veracity means. So to clean the data, it needs ETL kind of feature, and this feature is available in Apache Pig. Now, if you need to use the pig, you should know the language called Pig Latin, the scripting language. So that's the reason this language you should learn if you're using pig. And again, like for example, if there is a website and it's creating web logs, those will be created in the unstructured data that needs to be converted to a structured data, then you will be using pig. But yeah, nowadays they are not using pig. There is an alternative to it which we'll discuss in the future, but as of now, for our conversation's sake, we'll just think that pig is used for, you know, for cleaning the data. But again, I'm telling you, it's not so important. Nowadays most companies are not using pig, but yeah, I just wanted to let you know. And also pig is again also internally invokes Mapreduce job. So again, it is just an abstraction of the Mapreduce. So if you write code in pig, if you write the code in Pig Latin and do the data cleaning in using pig tool, internally, as soon as like as and when it goes down, internally Mapreduce job only will be invoked. Okay, so that is about pig. And coming to the HBase, Apache HBase. If you are wondering who will do the job of pig, if at all, let's say that if pig is not used, then what else is used? We'll talk about that. That's the interesting part. That is the interesting part. And actually the answer is Apache Spark, but we'll see what Apache Spark will do, okay, in the future. Okay, now HBase. HBase is a column oriented NoSQL database that actually runs on top of Hdfs, that is Hadoop distributed file system. This is just like any other like unstructured database like DynamoDB, MongoDB, or you know, all these things stored in like in a columnar. There is nothing much to explain in this. These will be stored as a documents. So in relational database system, we call tables and columns and rows, isn't it? So in NoSQL, the term is these are fields, okay, the columns are fields, the table is called collection, the columns are fields, the rows are documents. Okay, this is the difference. Just the naming convention is different. Okay, it's remaining, rest of the things are same, but the way they store the row, I mean the documents, the way the documents are stored in the collection is columnar, which means this will be in the JSON type of format. Okay, When you read it, it will be in the JSON format, which means what? It will be in the form of dictionaries. Okay, it will be in the form of dictionaries. Means what? It will be in the format of key value pairs. Okay, okay, just an explanation, a little bit of brief. We don't want to confuse more, right? We'll just go to the next one. Uzi. Now Uzi is, consider you have created a Mapreduce job and you want to run that job at 8 p.m. Indian Standard Time every day. Now, can you go and take the laptop and trigger the job at 8 p.m. every day? You might face many issues. Your laptop should be on, it should be charged, internet should be there, many things should be there. You know, what if you encounter some bug, whatever, it can be anything. No, you cannot always have the laptop on to trigger the job at 8 p.m. IST every day. Rather, you want to have some sort of mechanism that is scheduled that particular job to run at particular time, and you want to automate this. This is where exactly Uzi is coming into a picture. And Uzi is to automate the jobs in your project. This is a workflow scheduler. A workflow is nothing but a job that is been the sequence of things that needs to be done on the data. You want to pull the data, clean the data, transform the data. You want to do some manifestations on the data, transform it, make it into certain format. All these things together is called a workflow. Okay, and then a scheduling system, and then manages that particular job. Okay, and also Uzi is a recurrent workflow that is triggered by time, that is frequency, and also data availability. So it also manages the availability of the data, checks for the data availability present in the like in the virtual machines or no, and then also manages that particular job and takes care that what's happening to the job. That's the job of the Uzi. Coming to the most very important thing in the whole big data, if at all you are a big data engineer, if you don't know Apache Spark, everything goes to vain. If you don't know Apache Spark, 80% 80 to 85% of the big data depends on currently Apache Spark. Okay, what is Apache Spark? A distributed general purpose in memory compute engine. This is very important. The words distributed general purpose in memory compute engine. In fact, everything is distributed. If you remove distributed, it's actually general purpose. Actually, these three words, general purpose, in memory, compute engine, these are very important. Now let's a little bit go back. What's actually Hadoop? We know the core components of Hadoop. The core components of Hadoop are Hdfs, Mapreduce, and Yarn. We saw that in the first few slides. So Hdfs is what? It's a storage unit. And what is Mapreduce? It's a compute engine. And what is Yarn? It's a resource manager, cluster resource manager. So Spark is what? It's an alternative to Mapreduce, which means it's a replacement of Mapreduce. If somebody asks the difference between Hadoop and Spark, you should be polite enough to ask, excuse me, do you mean Apache Spark versus Mapreduce? Because Hadoop is component of all the three. Hadoop means it's a component of Hdfs, Mapreduce, and Yarn. So it's a replacement. It's an alternative to the Mapreduce. Mapreduce is a compute engine. Apache Spark is a compute engine. So if you want to differentiate, do it with Apache Spark and Mapreduce. Okay, that's the part. Now, the current industry structure actually right now, and moreover, yeah, what is this plug and play? Which means, so what I mean to say plug and play is plug and play component. Apache Spark is a plug and play component. It means you can stuff. If you do not want to use Apache Spark, you can use Mapreduce. So it's like a plug and play. This means Hdfs and Yarn is going to stay. Okay, Hdfs and Yarn are going to stay in that place. If you do not want Mapreduce, just plug this Apache Spark in place of Mapreduce. That is why it is called plug and play component compute engine. It just needs, Apache Spark needs what? It just needs a storage and resource manager to work with. You provide them with these two guys, Apache Spark will perform its best. Got it? That is Apache Spark. Now, old industry architecture was, they used to have a storage unit for HDFS as Hdfs, and resource negotiator as yarn, and for computing they had Mapreduce. But we know for some reason Mapreduce was very hectic. Not everybody could code. It was to be coded in Java. Very large number of code, many lines of code needed to be done. Needed to be coded. So that's why Mapreduce didn't become that famous. But eventually they were managing to write it in Java. But nowadays people are using in the current industry standard, that is Hdfs along with Spark and yarn. This is the current industry production standard that is being available right now. They are using. So what are the other, do you mean you really have to use only Hdfs and yarn as a resource manager and storage respectively? No, you can, your laptop can also, it's actually local. This is grammar spelling mistake, just ignore this. Local, it's a local storage. The storage can be Hdfs, the storage can be your Amazon S3, and or maybe your Azure Blob, Google file system, GFS, whatever in Google, whatever storage thing is there, all of these you can use as a storage. And do you need only yarn as a resource manager? No, who cares? If you do not want yarn, use Mesos or Kubernetes. All these are alternatives, and maybe you can say the tools for resource manager. But Apache Spark can come in between, and it's a plug and play. Like I said, it works as long as you give storage and resource manager, be it anything, it will work. So it's a compute engine, it's a storage, it's a resource manager. That's it. And let me tell you some important fact which I think it's not required, but still you should know. Hdfs is a data lake. S3 is a data lake. Azure Blob, or maybe it's combined with ADLS, that is Azure Distributed Lake, Azure Data Lake System service, also is a data lake. What's a data lake? It's a weird name. Data lake can store both structured and unstructured data. Got it? That's the only thing, as simple as that. In SQL and all these things, storage in SQL Server, Oracle Server, you can store structured data which will be in the form of tables, right? Which will be in the form of tables and rows. Okay, but what if you want to store a JSON? Can you store it? No, you cannot. So data lake can store. So HDFS is a data lake because it stores as a file system. You can store structured data, also will be stored as a file system. Unstructured data will also be stored as a file system. In fact, the file format will be the same, but we'll discuss more when we deep dive into Hadoop. But if you're thinking, oh, will there be a different format if I'm storing structured data, and it will be of different format if I store NoSQL data? No, it's going to maintain certain file format, and it's going to understand. He will understand. You don't need to worry. Hdfs or Amazon S3 or Azure Blob, whatever data lakes can understand. Leave the burden to them. They will know how to store it. So you can store both structured data and unstructured data in the data in Hdfs, S3 and Blob, and that they are called data lake. Now Apache Spark developers, when they developed this compute engine, they developed by using Scala language. Okay, Scala is the functional programming language. They built the Apache Spark using Scala. And what are the other languages you can use to again build data pipelines and write the programs in big data? That is Java, Python, Scala we already know, and R language. So you can write in Java. Still it is supported, but nobody writes in Java nowadays. But yeah, Python and R are kind of is still used, but even more than R, Python is used more. So Scala is in fact written, the Spark is actually written in Scala, so more or less the compatibility is there. But still Scala plus Spark works really well. but also the Python with Spark is called PySpark. It's widely used in the production industry. I mean, right now in the real-time industry, people are using Python with Spark because this is my personal opinion. Maybe there are some contradictions. People might say, hey, you know what, I use Scala in my company and our production and it's working something fine, but maybe it depends on the perception. I feel, even I was a very fan of Scala. Whenever they said that Python is good, I used to say no, Scala is good. Because I was working in Scala at that time. But when I moved to PySpark, I realized the huge difference, and there's a whole lot of libraries which are available in Python. If you do not know, if you're not entering into the Spark, you can still work with data frames. There are pandas and there are numpys. There's not much kind of this flexibility is there in Scala. There are too much of community. That's a large community for Python. Okay, that's the only reason. That's it. So that's about it, and thank you so much. If you liked it, please do share this video, watch this. If you have not watched the previous one, do watch that. Share this with the people who might need this. After this, we'll deep dive into Hadoop. Don't miss that. Take care, be safe.